Hello, everybody. This is Guillermo, and I'm really excited to be here with you today. Hope you're all staying safe. I'm here to talk about today about the post-Jamstack world and what that entails, and the rise of hybrid frameworks like Next.js. So I like to start by contextualizing kind of the state that we're in today and the problems that we're solving, and perhaps starting with a little bit of a grim message, but later on turns really optimistic, I promise, which is that the web is in jeopardy. And to illustrate that, I look back to 2018, a really interesting tweet that I have since kind of memorized almost, which talks about this website USA Today, and this gentleman Marcel went ahead and did a before and after performance audit by just removing a lot of junk from that website. A lot of unnecessary JavaScript requests, a lot of unnecessary downloads, a lot of unnecessary craft. And yes, he did remove the GDPR banner, but that's not really entirely what's wrong with it. So what he found is that before it would take, and I kid you not, 14,000 milliseconds. So that's 14 seconds to get to the first paint of this USA Today website. And after removing everything, pretty much, other than the text, and we'll get into why this concept of craft or additional JS is important or not later in the presentation, he found that he could bring everything down to 3 seconds. So he went from a load time of 45 seconds to 3 seconds. So this is why I think the web is in jeopardy. And by the way, this was in 2018, but the situation has really not gotten a lot better since. Because if you look at the progression of key metrics like first contentful paint and onload, and largest contentful paint, which is a metric that has emerged most recently, is pretty much, it's gotten better for sure, but it's pretty much been a very slow improvement. And when it comes down to metrics like first contentful paint and largest contentful paint, we don't see that big of a difference as we would hope. And that's what really this presentation is all about. Is I think we can make this a lot better, but we need to understand the problem fully, and we need to attack it in the best possible way with the best possible tools and with the best possible approaches. And before I go too much further, I think something that perhaps not a lot of presentations go into, which is this concept of what do we mean exactly by the web, right? Like we obviously all talk about it, but there's three properties that I think about when I think about the web that I would love personally to see improve, and a lot of organizations and businesses and individuals I think throughout the world would love to see improve. And one of the key things is that this web is global. So when we look at the data for how things have changed in terms of performance over the past few years, and we look at this orange bar line at the top, we'll see that India is possibly twice as bad as, for example, South Korea in this case. Um, and interestingly enough, India is where a lot of the growth is, a lot of where the best tech companies and unicorns are being created. It's where a lot of the people are coming online. So this matters a lot. And interestingly enough, that web that I'm talking about is also increasingly mobile, right? So I like to talk about this more recent data point, which I found from Josh Comio, where he talks about, the most common device in the world today. And guess what? That device is not the iPhone 12 Pro Max Super M1 Duper. It's actually more like this phone that you see on the screen here, which is a Xiaomi Redmi 8, and is the most common budget smartphone in India, which is one of these key areas that we're taking a look at. And one of the things he finds is that the web side by side, so on the right hand side you have an iPhone, and on the left you have this Xiaomi Redmi average Indian smartphone. So you can see that there's quite a bit more spinning on this website on the left, and that's a very, very optimized website with a lot of resources behind it. that in this case happens to boot up almost entirely on the client side, right? So it's not something that has come pre-rendered from a server, which we'll get into the benefits of it later. And actually, that's still pretty good, all things considered, because he goes on to say things get problematic when we visit news sites. And I think because of all the tracking snippets and such, it's a pretty good guess. These sites take forever. So here's the New York Times. And before we go on, for a lot of those of you that have already in your personal experience identified this problem with the web, because we all notice it when we just use the web every day, yes, this is going to be a little painful to watch. So let's take a look. So he's tapping on a story here, and you can see on the right-hand side, that actually still took pretty long for my liking personally, but notice that on the left, I'm speaking and it's still going. So this is kind of the reality of today, right? Like you can buy one of these phones on Amazon and run this test yourself. And what we're taking a look at here is what in our minds, in an oversimplified model, we could say, well, this is a super simple website, right? It's just like it's literally an online newspaper. How could it be like this, right? So he goes on to make a lot of interesting observations. One of them is that ad-heavy WordPress sites, unlike modern web apps, seem to be really, really bad for him. So he's touching on an interesting concept there, like the idea of ads and third-party scripts. Then he mentions every major React tab, and we're going to get into why this idea of that major React tab happens to be really relevant here. It says it's either server rendered or other forms of pre-generation. So he notices that boot up time is actually not bad. He does mention the time to interactive is slow, and we certainly need to fix that. So another great observation there. And he says that Next.js, for example, has done a lot here because Next.js in particular offers both server rendering and pre-rendering. So Gatsby is more focused on the latter, but he says that that's a property that is making that web feel faster, especially when you first load the page. And the third property I think about when I think about what is the web to me is that, and it goes into this concept of he makes the observation that major websites built with React are not as bad, is that the web is not all evenly distributed nor built alike. So another interesting tweet that came from one of the team members of the Google Chrome turned me to this idea of what does the traffic distribution of the web look like? And this is why I use the dragon emoji, is that I try to find an animal that both had a very long tail and B had a lot of potential that we can unleash. So one of the key insights from this telemetry that came from Google Chrome is that the head of the web, which is just 10 websites, represents 33% of global page views. And those are actually discrete page rendering. So we're not thinking traffic here, because we've probably heard the data that like Netflix has tons of the internet's bandwidth or whatever. This is in particular page views. So where are you opening a web browser to go to? And then the torso of the web, which is a lot of other websites, in particular 10,000. So the body of this dragon, the torso, is 10,000. That's also 33%. And then what's kind of interesting is that the long tail of the web is up to 3 million websites, depending on the device, and that represents 33%. So just torso and head, which is not that many websites, represent 50%. So if you consider like the top 1,000, actually, that's like the head and a little bit more, that's 50%. And if you consider head and torso entirely, that's nearly 66% or so. So what's interesting too is that if you correlate it with, if you go and look how these things are built, you start noticing a pattern or a trend that I think is really interesting in the context of thinking about Jamstack, which is the static web is more of the realm of that like long tail where there's more individual creators, or perhaps you fire and forget, you build it, or perhaps you use some sort of static generation tool and you just not update it as frequently. And for example, like long build times don't matter as much. But then as you start traversing into the more heavy traffic web, we notice actually the opposite. It's super dynamic, lots and lots of pages. You could never possibly build them all in a build process through CI/CD. And also we notice that it's hyper personalized. So each user is getting a different page, so there's not much that's static there. And that correlates a lot with what we're seeing in terms of that, where people are spending time and what technology is best suited for that. So in conclusion, the larger the site, the more likely that performance matters a lot, right? Because like if you're the New York Times, you're everywhere and you have a big business at stake. And then, and unfortunately, what we're seeing from all this, from the data and the anecdata, so the things that users are reporting or recording, performance is not really that great. So this made me think, I spend a lot of time thinking about like, okay, what is the difference between this monster that I'm going to call Faguzon? That's pretty cool. I hope I'm the inventor of that. So what's the difference between Faguzon? So these top 10 websites that seemingly have figured it all out. They're both dynamic and super performant, and they keep evolving fearlessly, and their page loads are fast. So what's the difference between them and the rest of the web? And some of the conclusions that we found is that if you look at, like, for example, how they consider front-end development, they have lots of teams supporting fairly advanced front-end infrastructure. And they have a unified approach, a unified framework, a lot of automation. Um, when it comes down to going to production, that's also very much automated. So the front-end developer doesn't have to figure out the production environment, and they can usually reproduce that production environment really well throughout the development process, and they're assisted by a lot of data. And finally, there's this idea of reusing. So reusing components, reusing design systems, and learning from the past. So there's a lot of sort of intelligence and historical data has been built up because frankly, those top 10 have had a lot of, a big of a head start, no pun intended, because they've been around for so long. So to fix it, I think we can take a page and we can learn from this. So what we're trying to do in our company is give you the framework, that unified front-end infrastructure solution, that unified tooling that continues to get improved without you having to deal with Webpack configurations and other implementation details, in a platform that you can fearlessly evolve the evolution of your front end in through preview deployments, constant benchmarking, testing your site and results in a real production environment, a global CDN, and so on. And one of the things that we noticed as well is that Nexus demonstrated that it has quite a bit of a fit, specifically in this top segment of the web, this most common sites, the ones where, frankly, you want to spend the most time optimizing because, like I said, number one, they have a reason to constantly invest in better performance, and their performance is not there yet. So our approach consists in wrapping React, which gives you this incredible unit of collaboration in the component. So you build a component and you can reuse it, and your entire team benefits from every improvement that you make to that component. I like to call it the Lego brick of the web. Then you can constantly preview your front end. So every time you push to Git, when you import your project into Vercel, you get a URL. You can see it here at the shop Git new checkout URL. And you can share that with the rest of your team. And then when you ship, everything around performance has already been figured out automatically for the entire team. But most importantly, what we've been noticing is that even though our motto is develop, preview, ship, it really is in this iteration phase and collaboration phase where a lot of the value in making the web better really resides. And when it comes down to iteration, and when it comes down to understanding performance deeply, I think one of the most important things is to have a very, very good lens of the reality of the state of your front ends and your websites. So the common expectation that I've seen sometimes in the ecosystem is, okay, so this is the sort of the image of the web. And I know that if I have a CDN that will ensure that everything is fast, and especially if it's been pre-rendered or statically generated, it's all good, it's fast. And then I think the only thing I need to do is figure out the size of my JS bundle. which that is like the other big thing. There's these two things, is that I have a fast CDN, I use Jamstack, static generation, whatever, and as long as I don't have a lot of JS on the client side, I'm good. Reality, however, is really quite different from that oversimplified model that a lot of us used to have in the past. So a CDN nowadays is kind of table stakes. Most websites nowadays have it, and we go to great lengths to automate it and make it available and free for you. But then performance becomes quite an interesting subject, quite an interesting rabbit hole. And I like to start with this example of box shadow because when Facebook rewrote their Facebook.com in the latest and greatest technologies in 2020 using React, and for the first time they were using the entirety of React, very similar to how Next.js works, where the entire page is driven by React, whereas in their past it used to be a combination of PHP and legacy technology and all that. So a gentleman went ahead and started doing what every web developer does, right? We inspect the open web. So they went ahead and like took a look at like how this new Facebook thing was being built. And this gentleman, Ahmad, noticed that the background at the very top was not box shadow with CSS. It was actually a background image. Yes. So the new Facebook, these experts of the web, the creators of React in 2020, were using an image, which for all of you that have been using the web for many, many years, like myself, you remember that this is how we used to do this like 10 to 15 years ago because we didn't have the box shadow property. So they're sort of going back. And why was that? So one of the performance engineers at Facebook graciously noted that it's for performance. A box shadow and the floating header like that was killing scroll performance in browsers. And Mateus goes ahead and asks, so I don't know if this is a silly question, but how do you guys test that? And this again, where like expectation and reality are a little bit not what we expect, which is honestly, you just scroll the page and you would notice. So like I said, teams like Facebook spend a lot of time worrying about performance, and obviously they get great results from that. And sometimes it's very sophisticated, and sometimes it's very much that good old, feeling test. So, and here's why I like to use this image of the iceberg, which is this mass of complexity that we tend to ignore in our oversimplified models has so many things that contribute to performance, like the latest web font that you copied and pasted from somewhere in the web with lots of CSS files and JS files and so on, your GDPR pop-up that comes from some third-party script, and your marketing team adds an analytics script, and then your product team adds an analytics script. And as Josh was mentioning earlier, the ads and trackers play a big role in exception reporting scripts and session recording scripts for product teams and images and your JS bundle. And I think here's where, the solution, which that tweet from USA Today was kind of alluding to, is where also I think we have to be on the side of reality, which is it's very easy to say, well, just throw all that away and then your website will be fast. And I'm actually willing to bet that that would be the case for the most part. If you throw all of that away, then I'm sure your website would be fast. But then I think these things got there not because we're intending to make the web slow, but because we didn't have the right workflow. In many cases, we didn't have the right tools. So for example, if you now use the Next.js image component, that image, which was a big part of the iceberg, because for example, you were giving a gigantic image that was unoptimized to a very small screen, now that gets fixed. So it's not that you had to remove the image, it's that you had to make it optimal. And that's where my sort of perception here is you have to focus on real solutions. Deleting all that sounds good, but it's not very realistic for most businesses. And one of the solutions really ends up being the good old cloud computing. And I like to use this stock photo that I found on Google Images because notice that like the cloud is streaming ones and zeros to a screen, which is actually pretty different from how the actual cloud works, but it's a good metaphor for, okay, instead of trying to run everything on my device, perhaps I can start doing some things at different times. I can start doing some things earlier in the life cycle. I can do them on the edge. I could do them on my server. I could do it at build time sometimes. And then it begins sort of a streaming one unified painting of the web that I want to deliver. So one of the strategies here that's quite obvious is, okay, so instead of doing computation on the device, shift it to the cloud. So all those spinners that we saw when the app was booting up on a slower device would have happened on a more powerful device, on a more powerful, literally machinery in the cloud. So, and this is where, for example, combining and starting to introduce server rendering or serverless rendering, like in our case, where you define a page that is not static and is also not deferring all the computation to the client side, but instead we leverage this asymmetry of computing, right? Because the computing on the cloud is more powerful than the one on the device. And this is really what the new generation of hybrid frameworks are enabling. So Next, Nux, and SvelteKit are examples of frameworks that can say, well, yes, this one page is static, but this other page can also do server rendering. So you're not locked in to a local maxima, to a peak of performance that could be done with static generation. And your only outlet is not just to put everything on the device, it's to also put it where it belongs. And this also comes from the conclusion realization that your CDN is not enough, right? So that time to first byte, that connection to a CDN edge and getting some HTML there is a very simplistic view of the problem, and it's very limited, and it's not how we're going to accomplish great performance. One of the ways that we can do this, because server rendering is also not a silver bullet, or just saying, well, I'm just going to use a hybrid framework, I'm done. That's also not the right solution. So when I mentioned the post-Jamstack world and the rise of hybrid frameworks, I'm not saying, well, just use a framework that comes with all these batteries included. You'll have to measure continuously as well. But this is why Next.js is also focusing on not just giving you, for example, a better image component that optimizes that part of the iceberg. And we have tons of other efforts ongoing for optimizing a lot of the other parts of that mass of ice. But one of the things we wanted to do early on is put you on a workflow and give you a workflow where you constantly get feedback about how you're doing, but from the perspective of the real world. So we call this a real experiences score. And what we do essentially is we take a subset of the same inputs that Lighthouse uses when you do a synthetic manual test, but we collect them from your devices. And then we give you a picture of like how well you're performing across mobile, desktop, how you're doing across different countries, how you're doing across different dimensions. So this is gonna help you, for example, not ship that box shadow because then perhaps it was slowing you down. And like I said, the nice thing is that it's integrated into the Next.js data source. So we know, for example, what pages, and we can help you find out what pages are contributing to the different breakdowns of scores. And what's really cool is that it's not just unique to Next.js. So we are working to enable this for all frameworks, starting with Gatsby, and more are coming very soon, where, for example, if you import your Gatsby project into Vercel, you're going to start getting a lot of these benefits of continuously thinking about performance from the perspective of your real users. So all that said, does it mean Jamstack is bad? Does it mean that putting lots of, like that J that encourages putting JavaScript in the client is bad? No, I don't think so. And I think it really depends on what you're building, and it really depends on what your ambitions are. And furthermore, it's not just that Jamstack is not bad, is that a lot of the ideas that were built into that stack, like the idea that the markup, the M, can be cached at the edge, and that you should leverage a lot of pre-rendering, that's a great tool as well. And you can start there. For example, in Next.js, you can make some of your pages completely Jamstack and completely static. And then you can combine it with a performance-oriented workflow where you're analyzing your metrics and you're really starting to ascertain if it makes sense for you or not. but you also always have that possibility of adding more. So my advice in that regard is you can use subsets of these ideas whenever possible. So when you define your pages, you say, well, this one is a static, and Next.js automates all of that. So you don't have to say, well, for this build process, I build statically and then I wrap it with a server and cache and purge. So the beauty of it is too that you really have to just define your pages and you're off to the races. And again, it's all about not limiting what you can do or how good your performance can be. If you want to learn more about Next.js and learn how these hybrid capabilities work, you can go to nextjs.org/learn. And later in the conference, Lee Robinson will be talking about specifically how this page generation and data fetching components of Next.js that enable pre-rendering, server rendering, and much more work. And you can deploy all kinds of frontends, whether fully static in Jamstack or the new generation of hybrid technologies. You can deploy them to Vercel for free. And by the way, you also get the ability to measure continuously. So the journey doesn't end at just deploying, but it really ends with and continues with learning from your users and ensuring that they're happy no matter where they are in the world. Thank you so much, and I hope you have a great rest of your conference.